Imagine two fighter pilots flying hundreds of kilometers apart. Neither aircraft is visible to the other, yet within moments, one pilot already knows exactly where the opponent is, what direction it is flying, and whether it poses a threat. In modern air combat, victory is often determined long before pilots ever make visual contact. It is no longer a contest of speed alone. It is a battle of information, sensors, electronic warfare, and precision. Among the aircraft built for this new era is the Dassault Rafale. Designed to perform a wide range of missions, it has earned the respect of air forces around the world. But how did this French fighter become one of the most capable multi-role combat aircraft of its generation? This is its story. Every remarkable aircraft begins with a challenge. For the Rafale, that challenge emerged during the final years of the Cold War. By the late 1970s, aerial warfare was evolving rapidly. Air forces expected their fighter aircraft to do far more than before. They needed to defend airspace, strike targets deep inside enemy territory, support ground forces, conduct reconnaissance, and operate in increasingly complex electronic environments. France, however, faced another problem. Its Air Force and Navy relied on several different aircraft, each designed for a specific mission. While each platform performed its role effectively, maintaining multiple fleets required separate training, logistics, maintenance, and modernization programs. It was an efficient solution for the past, but not for the future. France had a choice. It could purchase a foreign aircraft or join a multinational fighter program. Instead, it chose a more ambitious path: to design and build its own next-generation combat aircraft, one that would preserve strategic independence while meeting the demanding needs of both the Air Force and the Navy. The responsibility for turning that vision into reality fell to Dassault Aviation. Their mission was clear, but extraordinarily challenging: to create a single aircraft capable of replacing several specialized fighters without compromising performance. It was a bold decision, one that would eventually shape the future of French military aviation. On July 4, 1986, the Rafale technology demonstrator completed its maiden flight. Though not yet the operational fighter, it confirmed that France's next-generation combat aircraft was on the right path. Serving as a flying laboratory, the Rafale A validated its aerodynamic design, fly-by-wire flight control system, and other key technologies. Each test brought the aircraft closer to operational service. The program then evolved into 3 operational variants. The Rafale C became the single-seat fighter for the French Air Force. The Rafale B provided a 2-seat version for training and combat missions, while the carrier-capable Rafale M was reinforced for operations at sea. After years of refinement, the Rafale emerged as a true multi-role fighter, ready to become the backbone of modern French air power.
Designing a modern fighter aircraft is one challenge. Designing one that can perform multiple missions during a single sortie is another. For decades, air forces depended on specialized aircraft. One fighter gained air superiority. Another struck ground targets. Others carried out reconnaissance or naval operations. While effective, this approach demanded larger fleets and greater logistical support. The Rafale changed that philosophy. Instead of building separate aircraft for separate missions, Dassault Aviation created one fighter capable of adapting as the battle evolved. This concept became known as omnirole. Unlike traditional multi-role fighters, the Rafale can rapidly switch between different combat roles during the same mission whenever required. Achieving that capability required every sensor, computer, and weapon system to work together as one. That integration became the foundation of the Rafale's combat effectiveness. Modern air combat is not just about speed or firepower. It is about gathering information faster than the enemy and turning it into action. The Rafale achieves this through sensor fusion, combining data from multiple systems into a single, clear picture of the battlefield. Its RBE-2 AESA radar scans rapidly, tracks multiple targets, and delivers reliable performance through electronic beam steering. When stealth is important, the Front Sector Optronics (OSF) detects and tracks aircraft using infrared and optical sensors without transmitting radar signals. Protecting the aircraft is the SPECTRA electronic warfare suite, which detects threats, alerts the pilot, and supports defensive countermeasures. Together, these systems give the Rafale exceptional situational awareness, enabling pilots to make faster, smarter decisions, one of the aircraft's greatest combat advantages. Information alone cannot win a battle. Once a target has been identified, success depends on having the right weapon for the mission. That is where the Rafale's versatility becomes evident. The Rafale is designed to carry a wide range of air-to-air and air-to-ground weapons, allowing it to be configured for different operational requirements. For beyond visual range combat, it can carry the Meteor missile. Powered by a ramjet engine, Meteor maintains energy over long distances, making it highly effective against maneuvering targets. For shorter range engagements, the Rafale employs the Meteor missile family, providing flexibility across different air combat scenarios. Against ground targets, it can deploy the Scalp cruise missile for long-range precision strikes and the AASM Hammer for accurate attacks on tactical objectives. The aircraft also carries a 30mm internal cannon, which remains effective for close-range engagements and support missions. What truly sets the Rafale apart is its ability to integrate these weapons with its sensors and mission systems, enabling faster and more effective target engagement. The true measure of a combat aircraft is not taken in the factory or on the test range. It is measured in real operations, where demanding missions test both the aircraft and the people who fly it. Since entering service, the Rafale has been deployed by France in Afghanistan, Libya, Mali, Iraq, and Syria, carrying out missions ranging from close air support and reconnaissance to precision strikes and air policing. Combat experience has driven continuous upgrades to the Rafale's software, sensors, and mission systems, allowing the aircraft to evolve throughout its service life. The Rafale has also been selected by Egypt, Qatar, India, Greece, Croatia, Indonesia, Serbia, and the United Arab Emirates, reflecting its growing international presence. Its continued service and ongoing modernization demonstrate that it remains an important part of modern air power. Among its international operators, one acquisition drew particular global attention: India's decision to induct the Rafale into the Indian Air Force. Every nation chooses its military equipment to meet its own strategic needs. For India, the search for a new multirole fighter was driven by the need to strengthen its air power for future challenges. After an extensive evaluation, India signed an agreement with France in 2016 to acquire 36 Rafale fighter aircraft. The first aircraft arrived in 2020, marking a new chapter for the Indian Air Force. Configured for India's operational requirements, the Rafale introduced capabilities such as the Meteor Beyond Visual Range missile, the Scalp cruise missile, advanced sensors, and electronic warfare systems, significantly enhancing the IAF's operational flexibility. Rather than replacing every fighter, the Rafale became part of a balanced force alongside the Su-30 MKI, Mirage 2000, MiG-29, LCA Tejas, and other platforms, each serving a distinct role. Today, it serves with No. 17 Squadron, the Golden Arrows, at Ambala, and No. 101 Squadron, the Falcons, at Hasimara, contributing to missions ranging from air defense to precision strike. But no combat aircraft is perfect. To understand why the Rafale is respected around the world, we must also examine its strengths and its limitations. Every combat aircraft is the result of thousands of engineering decisions. Designers constantly balance speed, range, payload, agility, and cost. There is no perfect fighter, only one designed to best fulfill its intended mission. The Rafale's greatest strength is its versatility. Designed as an omnirole fighter, it can perform air superiority, precision strike, reconnaissance, maritime operations, and nuclear deterrence missions from a common platform. Combined with advanced sensors, electronic warfare systems, and a wide range of weapons, it provides exceptional operational flexibility. Another key advantage is its continuous evolution. Regular software updates, new weapons, and capability enhancements have allowed the Rafale to remain effective as technology and operational requirements continue to evolve. Like every modern fighter, however, the Rafale also involves trade-offs. Rather than relying primarily on stealth, it combines reduced observability with advanced electronic warfare, mission flexibility, and tactical adaptability. These reflect different design philosophies rather than simple measures of superiority. Ultimately, no fighter wins battles alone. Pilot training, mission planning, logistics, intelligence, and maintenance are just as important as the aircraft itself. That is why the Rafale continues to earn respect, not because it is perfect, but because it was designed to adapt, evolve, and perform across an exceptionally wide range of missions. Modern air combat is not just about speed or firepower. It is about gathering information faster than the enemy and turning it into action. The Rafale achieves this through sensor fusion, combining data from multiple systems into a single, clear picture of the battlefield. Its RBE-2 AESA radar scans rapidly, tracks multiple targets, and delivers reliable performance through electronic beam steering. When stealth is important, the Front Sector Optronics (OSF) detects and tracks aircraft using infrared and optical sensors without transmitting radar signals. Protecting the aircraft is the SPECTRA electronic warfare suite, which detects threats, alerts the pilot, and supports defensive countermeasures. Together, these systems give the Rafale exceptional situational awareness, enabling pilots to make faster, smarter decisions, one of the aircraft's greatest combat advantages.